Welcome to another OpenShift Commons briefing. This time we're going to talk about IoT Edge deployments using OpenShift and RHEL. And we've got a whole crew of folks from our Italian offices, Luca, Gabella, Luca Bigotta, and Alessandro Arrichiello. And I'm probably killing their names, but that's my normal thing to do. And I'm going to let them do the talking and introduce themselves. The way that we do this is if you have questions, ask them in the chat. We may reiterate them verbally so that we get it captured on the video. And then there'll be live Q&A at the end. So without any further ado, Luca, and Alessandro, take it away.
Thank you, Diane. So good morning, good afternoon, good evening, everyone. I am Luca Gabella. I'm responsible to develop the Internet of Things activities in EMEA for Red Hat. And together with my colleagues, Luca Bigotta and Alessandro Arrichiello, Solution Architects for Red Hat, we will run this webinar. Today, we would like to introduce you a use case leveraging OpenShift distributed containers capabilities within an Internet of Things context. So the webinar will be divided in two parts. The first one, we will make a presentation of the solutions, and we will go through a recorded demo to illustrate this case. The second part of this webinar will be dedicated to a Q&A session. So, starting with Internet of Things. Internet of Things is a complex topic. We won't go in details, in deep dive this topic in this webinar because we won't have enough time to do this. But in a nutshell, Internet of Things is a capacity, if I have to describe it in a nutshell, it is a capacity to gather data from the physical world, eventually integrate it with other sources of data like weather, social media, enterprise processes or whatever, elaborate them in real time, and extract the values that will be used to run specific action or processes. So in the enterprise world, the supported architectures is typical of an IoT solution is typically defined in three tiers. The first tier is made of sensors enabled to interact with the physical world through specific industry standards and protocols. The second tier is made of concentrators or gateway that gathers the data from the field, from the first tier, that typically sit at the edge, closer as possible from where the data is generated. But more and more, it is required to these tiers to become more intelligent through complex data elaborations, application running in real time, essentially. Then we have the last tier, that is the data centers, where the Internet of Things solution is orchestrated through automation procedures, where the data is elaborated, captured, injected in the different enterprise processes. Just to come back to the second tier that sit at the edge, it's typically facing various environments, sometimes to time very tight in terms of physical constraints, and sometimes also very demanding in terms of computational power and application to run. In today's use case, we will demo in these webinars basically the targets for the type of IoT use case we have in mind is typically when the edge is requested to do very complex processing powered activities, and let's say this is typically when they have to run very complex applications and manage multiple types of data elaboration. This use case was inspired by several customer discussions we had in these last months, where typically the customer had asked to be capable to develop application centrally and then deploy it easily up to the edge, update them, and eventually remove it from the edge. So this is typical situation that we can face in some specific, let's say, request from the customer side. And here in this slide, we try to summarize four typical cases we see this type of use case we will demo today can be used. The first one is when we have a typical industry situation, manufacturer who has distributed plants all over the world and need to connect this plant and deploy applications that have been developed centrally. This thing is similar to some actors we are also talking with in the oil and gas industries, where, for example, they have platforms and they need also, multiple platforms in different oil or gas fields, and they need to deploy new application. Another one we are seeing is in the fleet of boats to be managed, typically the cruise boats and so on. And the last one is in some cases where the players have deployed very complex machinery that embedded inside CPU, deep CPU powers, and need to deploy specific application depending on the context where this machinery are used. So, setting this, I will now let the words to Luca, who will describe in detail this use case that motivates this webinar.
Thank you, Luca. So, the idea for the solution we built and we show you today during this webinar come from a discussion we had during a meeting with one of our prospects in the manufacturing area. This prospect was looking for a solution to manage the deployment of application, typically business application, from a central data center to the edge. At their headquarters, they have on-premise a server farm on which they developer teams, both internal and third-party people from system integrator team, works together on build and test application. They also starting adopting a platform as a service architecture based on Linux container. Central server farm and edge are different in architecture. So Docker container format, it seems to be a simple format on which structure the package of the application and dependency in a portable object to be moved from the center to the edge. We also show them the possibility to adopt a continuous integration, a continuous deployment chain on the data center to gain benefit like DevOps, test automation, and promotion automation. We were dealing with a manufacturing company with a main IT data center at the headquarters and many plants. In every plant, we find a small local server farm acting as a plant hub or gateway hub to connect edge elements like microcomputer connected to the production machine. Their plants are distributed around the world, so we also had to consider the complexity come from geographic distribution. So our solution consists of a DevOps environment on the main data center on which developer teams work on build and test application as a Docker image, an automation tool chain to execute automation test, promote the image in different environment on the same data center, and then when the tester passed, deploy the same image to every hub gateway on every plant, the factory, and from the hub gateway to edge node. In a comprehensive IoT scenario, the deployment solution we built could be focused on move to the edge business application, and it could be combined and integrated with a technical solution more dedicated typically IoT domain aspect, like data and event gathering from sensor, field connectivity and machine sensor, device management, etc., etc. Now, Alessandro will give you details on the solution.
Thanks, Luca. Now we'll talk about the technologies and our involvement in the use case scenario. First of all, we can support the customer in the full stack with Red virtualization on top of physical machines, spawning new virtual machine for example, a platform as a service. This platform as a service could be Red OpenShift, of course, use it in the data center as a development environment and as container platform for internal data center services. The full Red Hat stack could be used in the factory for creating an hub that at the end let you manage more closely the edge deployment. The edge machines could be Red Hat Enterprise Linux running containers engines like Docker, and we can handle the deployment with Ansible Automation Suite. But how do we handle it? Actually, as we said, we can easily install and use OpenShift both on central data center and on the factory. Then we can leverage on the OpenShift CI/CD features with Jenkins, for example, for handling all the development needs. Once built, the container could be moved between the environments, for example, from development to test, from test to prod, and also to the factory. Arriving to the hub and finally to the edge machines running standalone Red Hat Enterprise Linux. And both OpenShift on the data center and on the factory may also share the same OpenShift container registry, and the edge deployment could be held through Ansible. So just for recapping the technology involved, we have Red Hat virtualization on top of physical machines. Then OpenShift, of course, used in the data center as development and also for internal services. And finally, Ansible automation tools for handling remote deployment on Red Hat Enterprise Linux standalone machines. Before going in deep on the recorded demonstration, I would like to better explain what we will see and how we manage achieving it. First of all, we reused a demo that was developed for a Red Hat Summit a few years ago. And as you can see by the slide, it's made of different components. A sensor application that sends temperature data using MQTT to a Red Hat MQ broker. These messages will be forwarded to a business rules service that finally will trigger a DC reduction when the sensor value reaches a threshold. As you can see, the demo uses all Red Hat products, so Red Hat Enterprise Linux, Fuse, Decision Manager, MQ, and it represents an example of intelligent gateway on the edge. Talking about the demonstration, we firstly containerized the demo, creating multiple GitHub projects for every single component, and a placeholder project describing the whole demo. We then set up all the deployment config, build config, and services for running containers on OpenShift. As you will see in a few moments in a recorded demonstration, we also integrated for every single project and containers a Jenkins pipeline that actually build, deploy, and promote containers between different environments. Going in deep in every component, so we have the software sensor, that is an application that produces simulated temperatures and send it to an MQ topic handled by an MQ broker. Then we have the Fuse routing service component that take the software sensor messages and move them on a QA, monitored by the business rules, empowered by the decision manager. And finally, we have this business rules component that checks the received value, and if it reaches a threshold, will trigger a message on another QA. So Actually, we'll see in the demo an OpenShift container platform, so an only one container platform simulating both the data center and also the hub on the factory using 3 projects: the development project, the testing project, and the hub. Finally, we'll have also an external standalone Red Hat Enterprise Linux running the spare containers on top. As you can see, we have 4 containers running on the development environment and the testing environment, where the containers are built through Jenkins pipelines and tested. We have also an hub project on the same OpenShift platform, simulating the factory's hub. And this project will handle only the MQ broker containers for receiving the data from the edge, basically. As we'll see in a few moments, the final edge deployment of the remote Red Hat Enterprise Linux is handled through an Ansible service broker feature of OpenShift. So, just before going in the demonstration, as we said, we create as a part of the demo an Ansible playbook bundle pre-built in the OpenShift service catalog that will start the edge deployments thanks to the Ansible service broker. The Ansible playbook bundle contains all the credentials needed for connecting to the remote Red Hat Enterprise Linux and the playbook for deploying the containers. Of course, this is just an example, and in a real massive use case scenario, this technique would be evolved in using Ansible Tower that offers an enterprise management console for Ansible workloads. In the next slide, we will watch at a demonstration we recorded of the running example on a real OpenShift platform, and we will comment it live. So first of all, this is the GitHub page of the original demonstration that was presented at the Red Hat Summit a few years ago. And as you can see, is already created around Red Hat Enterprise Linux, then using JBoss Fuse, VRMS, now named Decision Manager, and AIMQ. And this was an example of building an intelligent IoT gateway in a very few easy steps. Then we created a project on GitHub, a placeholder for all the instruction, prerequisites, and links for all the other projects involved that you can reuse for deploying the same demo on your OpenShift environment. Moving to the OpenShift container platform, as you can see, this is a platform built on Azure, running already the container catalog with 3 projects: the development and the testing and the hub, as we said before. And we will start going in deep in the development environment. As you can see here, there is an MQ container handling the QA for messaging, then a business rules container handling the rules, a Jenkins container that we will see in a few moments will handle builds and pipeline, a routing service Fuse container, and then a software sensor that produces simulated temperatures. All the environment is up and running, and we can see that actually the software sensor is already producing temperatures and sending to the MQ broker. And then we can also inspect and take a look at the builds we created for creating the final container that we will be deployed at the edge, and then the pipelines created and used by Jenkins for handling the build and then the test, and finally the deploy of the container in the development environment. At the end of the deployment, there is also a tag action, a tag step that will tag the current development image into the testing environment, promoting that kind of image. We can also start, for demo purpose, the pipeline that will produce a brand new image. Talking of images, we have only 3 placeholders because we will use the MQ broker image from Red Hat Container Registry. And then we have the same 3 placeholders also for the IoT testing environment. This one will be populated by the Jenkins pipeline. Moving to the IoT testing environment, we can see actually we have the same architecture, the same structure of the development environment, so the same element and containers, but we have not built neither pipelines created. This is just because we prefill the Docker image stream of OpenShift with the Jenkins pipeline, tagging the development images. Moving to the IoT Hub project, actually, we will see that only the MQ containers is running, and this because we will use this broker for receiving messages from the edge. Then we will spawn and deploy images to the edge thanks to the testing image placeholder. Then moving to the container catalog and choosing between the services, as we said, we created an Ansible playbook bundle named IoT Remote Container Deployer that requests the IP address of the remote RHEL to connect and start the container deployment. So before creating this element, this service, we can connect to the cockpit interface of the remote Red Hat Enterprise Linux server. Cockpit is just a web interface that lets you manage remotely a Red Hat Enterprise Linux. And as you can see by the overview page, this is just a virtual machine running on top of Azure. This is just a RHEL, not an OpenShift node. So it's just a RHEL plus Docker with a cockpit interface. We enabled the containers tab also for watching the containers. And as you can see, there are no running containers, but only some images in the cache from previously created deployment. The containers will be provisioned thanks to playbook we already wrote and integrated in the catalog. And as you can see, this playbook will use the Docker image module of Ansible for pulling the images from the externally exposed OpenShift registry, and it will download the IoT testing project images. Then it will kill any previously running containers and start one by one all the needed container at the edge. The last one will be the software sensor. We can then create the service, and in the meantime, OpenShift will instruct and run an Ansible container that actually will connect to the remote RHEL at the given IP address for starting the edge containers. As you can see, the MQ containers is started, then the routing service. After that, we will see the business rules containers will be pulled and then started, and at the end the software sensor container. All the chain is working properly, and we will see in a few seconds that actually the software sensor already just started is already producing simulated temperatures. These temperatures will be sent to between the chain directly to the MQ broker in the OpenShift container platform, so in the hub, and we can see that actually this broker is receiving messages looking at the MQ console. As you can see, the messages are increasing, the number of messages are increasing, so actually all the stack is working properly. Moving back to the OpenShift console, we will see that actually as we provision it and then created new containers at the edge, we can also deprovision them by deleting the created service. As you can see, the service looks already deployed, created, and then we can click delete, accept the deletion, and then moving to the standalone Red Hat Enterprise Linux, we will see in a few moments disappearing and killing the running containers from cleaning up the previous deployment. As you can see, the images still stay in the cache for future deployment and speeding up the deployment. So this ends the demonstration, but just for recapping what we saw how could be easily to use OpenShift as a development environment for testing, building application that could be moved and then run in the edge as a container. So the image is only built in the development environment, then promoted in the various project environment that we will create. Then we flow to the hub directly to the gateway using Ansible. Of course, in a real use case, a massive scenario, this could be replaced with an Ansible Tower that offers a web interface and all the tools for enterprise handling these actions. So it's time for question.
Excuse me. That's very complete and wonderful demonstration. So thank you very much for the presentation. I'm curious, this was a demo that I did indeed see, or a version of it I saw on stage at Red Hat Summit. I'm wondering if you have examples of people who are now using this at scale in production out there yet, or if this is still something that's mostly just in reference architecture phase.
Okay, so the thing is, we do not have live case right now. We are working with a couple of customers. I mean, the use cases are the example of, let's say, targeted industry we just mentioned in the beginning of the presentation are the type of people we are discussing with. Yeah. So you know, the deployment of this kind of a real scales take a lot of time, because the Internet of Things deployment is not only the digital part that is difficult, is also all the rest, the deployment of the physical part, the re-engineering of the process, and so on. This allowed to have a significant change in the way they used to run application and deploying application, or sometimes they did not make any deployment of application because they were not the available technology yet. But it's very interesting that the people we are talking with are designing architectures with these intentions to deploy application containerized as close as possible to where the data is generated. So this is, we have several cases, but obviously they are pretty sensitive cases, but it's under discussion.
Yeah, no, I don't expect you to name names or anything. It's just that this is a similar conversation that we've had in the automotive SIG and in other places as well, because, you know, not just to factories, but to automobiles and other moving vehicle type things to get to those edge networks as well. So it's there's some overlap, I think, in the conversations that we're having in different market spaces, even amongst the Red Hatters. So it'd be interesting to bring everybody together and see if some of this can help with other folks. And I actually think they probably have used some of this stuff in production at some of the automotive, at least at POC stages, from what I can. And as well with telcos, there's been a lot of conversations around the edge networking stuff. So it's definitely it's one of the new hot areas for us to continue to help build reference architectures and get the information out there about how to do this. It'll be interesting to see as the people you're working with go public with their POCs and give their lessons learned and best practices to get them to come back and tell us, you know, what they did and where they can share their content.
Yeah, the main issue at the moment is actually in Kubernetes and OpenShift as well, because it uses Kubernetes as a container orchestration. You cannot set up an isolated node. And so Ansible and Ansible Tower can help for deploying and automating the deployment, because OpenShift is really powerful in developing new technologies, in new prospect, in creating new project. But of course, you need to add then some automation layer for handling the deployment to the edge. And so that's why we thought about this solution.
I think it's a great use of Ansible Tower and Ansible playbooks for the automation. One thing I'm sure of is that OpenShift doesn't solve everything. We have to use a lot of other tools in our toolbox to make this happen. And so it's really good to see. I don't see any questions from the audience in the chat. There's a lot of folks on listening and being very quiet. So if anyone has a question, please put it into the chat. Do you have a resources page in your slide deck? You mentioned a lot of links there. So if not, what I'll do is I'll ask you to send me the links, and we'll post this together with the links to all your things and how to get a hold of you.
Yeah. There are some questions.
No.
Yeah, they're asking if there's a GitHub repository for IoT Edge, and I think you popped on one, but I think it was under Alessandro's name. If I did it fast enough. Yeah. So, and I think that's something that we should probably do is create, and I offered, I offer up OpenShift Commons because we have a number of topic-specific special interest groups that maybe if people are interested, we can create a landing page in OpenShift Commons for these discussions, and also create some GitHub repo links and things like that as well. And there's Luca just posted the GitHub for this project and for this demo in the chat as well. Are there any closing thoughts and words that you might want to add in, Luca's and Alessandro?
No, at this stage. I think this is something that is coming from real demand. We are under discussion, so we hope to have more things to add in the near future. But I mean, this is something that it's a real need. Not everyone is, I have to say, is today on the market mature to understand this new potential. So obviously there are some work also of introducing it to the market.
And that's really what we're trying to do here today. Is we're not saying that this is is there yet a reference architecture document for this topic?
Not yet.
Not yet.
That's what I would push you to do, is to get that content out, get the video out. We'll create a SIG. We'll get people talking. But I think, and we'll pull in some of I know the folks in the automotive and some of the folks in Japan have done a kind of an edge networking talk previously, probably about a year ago at an OpenShift Commons gathering. Hyde Tsukiyama did one. So what I'm thinking is that now is the time sort of to pull everybody together and get some of the requirements and feedback from outside of Red Hat and start building a community around this content. So I look forward to doing that with you all. So thank you very much for coming today. And we will post all of this on YouTube. And if everybody sends me their slides, I will then post it on blog.openshift.com or openshift.com/blog, actually. And we'll get that up there for you all. So thank you very much.
Good, Diane.
Thank you.
Thank you, everyone.
Thank you all.